The Nikon D300 and D700 cameras are marvels of engineering. With dozens of custom settings and shooting menu options, you have the ability to store banks of information for specific image configurations and camera customizations. Once you have it all figured out, you'll never take a bad picture again. Or maybe it's a little more complicated than that. Hi, I'm Tim Mantuani. I've been making a living with camera in hand for close to 20 years. Just like you, every time I upgrade to a new model, I'm faced with more choices, options, opportunities to really mess things up. We created this training DVD with 3 goals in mind. The first is to help you understand the advanced technical settings and what they were designed to accomplish. Second, we want to help take you a step back and see how different camera settings relate to the physical environment. Our third and final goal is to explore how these settings are affected by downstream digital processes, like your computer display, post-processing steps, and printing an image. After all, you do want your images to be seen.
The information in this DVD applies to both the D300 and the D700. For the purposes of this presentation, the D300 and D700 are virtually identical. Any differences between the two models will be noted. We will use the D700 for all of our technical demonstrations in the studio, and then use the D300 for all the real-life demonstrations with Tim. Before we get started, it is important to understand why we produced this DVD and how it can be beneficial. Our introductory training DVD covers basic camera operations and beginning photography concepts. It is intended to give new users a general understanding of the camera. If you need a refresher on camera operations or in the basics of metering, focus, and color temperature, we suggest you watch this disc before proceeding. Blue Crane Digital also produced a 2-volume set called Through the Eyes of a Pro. The set is intended to develop your skills as a photographer. The presentation does not focus on any specific camera controls. You might say Through the Eyes of a Pro addresses the artistic and business sides of photography. Think of the training DVD you're watching as a bridge between the beginning and advanced presentations. Just as modern digital photography is a blend of technical competence and artistic choices, this DVD will attempt to tie together the technical, the artistic, and the physical realities of image making. In the years since the first digital SLR cameras came out, the technology has improved at every price point. Each successive model brings with it new options and controls. For instance, although the Nikon D100 was considered a great camera a few years ago, the technology offered today eclipses it. The D100 took great photos, and it still can. So, are the new settings offered in the D300 really necessary? That depends on your needs as a photographer. In order to develop a personal photographic style, you need to take a more in-depth look at the camera functions and custom settings. Then determine whether and how they apply to your shooting style.
We've divided the DVD into 4 main sections. The first section will deal with exposure, focusing, and shutter release. Although many of these settings are either in the custom settings menu or a programmable button, we'll take this into the real world and tie the settings to the subject you are shooting, the physical environment, and the equipment you are carrying. In the second section, we're going to talk about commander mode for flash photography. Nikon has upgraded the capabilities of commander mode in the D300 from earlier models. Adding light through the creative lighting system and Nikon speedlights can have the biggest and fastest impact on the quality of your photos. Although this won't be an exhaustive discussion on the creative lighting system, you will have enough understanding at the end of this presentation to use wireless remote speedlights with confidence. Third, we'll focus on color. We'll cover the settings that affect both the acquisition of the color properties you want and settings that may affect the final printed or displayed image somewhere down the post-production path. In each case, we'll bring you back to the camera setting so you understand what your choices mean after the shutter button is fired. Last, we'll spend a short amount of time talking about organizing all the advanced features you've learned about. Although the menu system and custom setting screens are well organized, unless you have a structure that makes sense for you, all the technical choices will be buried somewhere in the menu system. Having your preferred settings organized will help us get to our goal, taking consistently better photos.
Some of the technologies we'll cover can be helpful, but you are now at a crossroads as a photographer. To use your camera to its best advantage, you will need to stop relying on technology alone to create the image. Instead, balance technology with everything happening in your physical surroundings and the choices you make as a human holding this black box. That's what photography has always been about. Let's explore more of this camera in the real world. In the introductory DVD, we explained how focus mode combined with AF area mode allowed you to decide how and when the camera would focus on your subject. This camera also offers specialized settings that give you even finer control over the autofocus system. We will begin with the custom settings menu. Although we touched on these settings in the first volume, we will now tie them to real-world examples. The Custom Settings menu allows you to reprogram buttons, customize the flash sync, and tweak the camera in dozens of ways. You will probably find that while some of these settings will help your shooting, many will not fit into your particular routine. The custom settings are broken down into logical groups. The first group, A, consists of settings that control the camera's autofocus functions. We'll begin with custom settings A1 and A2. With these settings, you can determine whether the camera must achieve focus before releasing the shutter in continuous servo and single servo modes. Normally, you have to wait until the focus is locked to take a photo in single servo mode. This is called focus priority. Alternatively, when the camera is set to continuous servo, the shutter will release regardless of whether the scene is in focus. This is called release priority.
We're at the Velodrome here, and this is a great public venue that you can come to practice your photography. And the great thing is about it is the people are going to come by in a continuous, cycle every time. So you can practice fast shutter speeds, slow shutter speeds. You can work on your different focusing techniques and the different modes that the camera has, and take a lot of pictures. I mean, I've been doing this for a lot of years, and I still take a lot of crummy pictures. But you just got to get out there and practice, 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 and this is a great spot to do it. We're going to be looking at the custom settings A1 and A2 for shooting action, both the subjects coming at the camera and coming across the frame. So let's take a look at the focus modes and see what works best for this situation. In A1, there are 3 different modes to shoot in. There's release, release plus focus, and focus. In release mode, it simply means when you push down the shutter button, it's just going to shoot. It doesn't matter if the image is in focus or not, it's just going to fire as many frames as it can. In release plus focus, it's going to be a combination of finding a focus and just trying to shoot as many frames as possible. And in focus mode, it's not going to shoot unless the image spot that you want to be sharp is sharp or something is in focus. If it's not in focus, it's not going to shoot any frames at all.
Attention riders!
Here I have the camera set in the default mode of release priority. Let's see what happens when I shoot the racers as they ride towards me. As you can see, the camera and lens do a pretty good job of keeping up with the racers. Still, some of my results are out of focus. This is more likely to happen when the riders are coming towards me because they are advancing through the focal plane. Contrast that to what happens when the riders pass in front of me. Here they are moving through one focal plane. This is when release priority will work the best. Your distance to the subject doesn't really change as the cyclists cross in front of you, so every shot will be in focus.
So since these guys are coming at me from the side a little bit, it's not quite as hard for the lens to figure out a focal point as if they were coming right into the camera.
They like to call themselves the aces. Most of the category A's hold at least a state championship.
And I try to find the most important part of my image to be in focus that I want the eye to go to, and then not worry about anything else.
Next, I change the A1 setting to focus priority. Again, this means the camera must achieve focus before it records the image. I get another series of shots as the racers ride away from me. They're moving through the focal plane, so the camera is relying on predictive focus tracking to adjust the focus. I won't get as many images this time, but they will all be in focus. So that covers a little bit about shutter release mode in A1. There's several factors which you have to take into account: your lens, your shutter speed, and your aperture. And we're going to show you a simple exercise on how you can practice this.
The following experiment will demonstrate why Nikon offers both the focus priority and release priority options in continuous servo mode. For this assignment, you will need a lens with a focal length of at least 100 millimeters. Set up your camera on a tripod near a busy street. With the camera set to dynamic area AF, select the center focus point. Set the release dial to high speed continuous so you can take lots of images in a row. Next, access custom setting A5 and select AF on only. This will disable autofocus in the shutter button. Again, because it is in the A group, you know this setting controls something on the autofocus system. Also, check to make sure the custom setting A1 is set to release priority and that the camera is in continuous servo mode. Finally, open up the aperture to create a shallow depth of field. That will make it easier to see the effect release priority and focus priority can have on your images. Now, pick a starting point and an ending point on the opposite side of the road. You want them to be in roughly the same focal plane. As a car approaches the starting point, press AF on. Take as many photos as you can, panning along with the car. Reposition the tripod to face the traffic on your side of the street and pick another starting point and ending point. Press AF on and take a series of photos of a car as it moves toward you. For the second part of this experiment, you will need to change custom setting A1 to focus priority. Take both sets of photos again, using the same starting and end points. As you shoot these images, listen closely to the shutter release. You will likely hear the camera pause briefly a few times. During those pauses, the camera is working to focus on your moving subject. So, what are the differences between release priority and focus priority? The number of frames per second drops when you switch to focus priority mode, but the real difference becomes evident once you take a close look at your images. Look at the photos of cars that moved parallel to the camera. Notice that in both release priority and focus priority, the camera maintained focus. This is because the car moved straight across one focal plane. Since it didn't get any closer or farther away, once focus was achieved, all the successive images would be in focus. In contrast, consider the photos you took of the car that moved toward the camera. This subject crossed countless focal planes as it approached. The camera tracked the car as it moved forward and adjusted the focus. However, some of the images taken in release priority mode were recorded before the camera had time to complete the focus. As a result, those images are blurry. The photos taken with the camera set to focus priority are all in focus. So, whether you keep custom setting A1 on the default or change it to focus priority really depends on the kinds of images you take. If you like to shoot race cars as they speed past, then the default setting of release priority will work really well. Since you will be shooting a subject that remains in one plane, virtually all of your shots will be in focus. Best of all, you can shoot at the maximum possible frame rate. Another alternative would be to select Release plus Focus Priority. This setting gives you an edge because while the frame rate is slightly slower, the extra time gives the camera more of an opportunity to focus on your subject. If you shoot subjects that move erratically, such as stunt airplanes or flying birds, then you may prefer the Focus Priority setting. Here's why. These are subjects you will shoot from a great distance using a telephoto lens with a long focal length. The longer lens gives you a very shallow depth of field around your subject. There is so little latitude that if the subject moves erratically, your shot will go out of focus. If the camera is set to release priority, your chances of getting a clear shot will be very low. Instead, shoot in continuous servo mode with focus priority. Because it's continuous servo, the camera will engage predictive focus tracking in order to keep up with the moving subject. However, the focus priority option will ensure the focus is locked in before you take any shots. Another factor to consider is the quality of your lens. A high-end lens may do a better job of keeping your subject consistently in focus, even when it is moving toward or away from you. Lower-cost lenses may not focus as fast. With these lenses, the focus priority setting may make the difference between getting a blurry shot and the shot you want. But don't get obsessed with the idea of getting perfect focus. Sometimes you can create more interesting images by turning autofocus off and allowing the motion to change the image.
Now I'm just going to a slow shutter speed and shutter priority. I'm just panning action with the cyclist, and I'm going to get just some very unpredictable results, but usually you get some cool stuff. Good. I'm going to do a pan action shot here in shutter priority at about a 1/13 of a second and see what I get.
Next, we'll look at custom setting A2. Again, you choose between release or focus priority, but this time for shots taken in single servo AF. The default is focus priority. It seems like this is a setting you would never change. After all, why wouldn't you want to ensure that every shot is in focus? Well, in rare cases, release priority could allow you to get the shot you want. For example, say you want to take extreme macro shots of your subject, but the autofocus system won't lock on the correct point. Try changing custom setting A2 to release priority. Use AF on to get the closest focus you can on the subject. Then, turn the focus ring on the lens to bring the correct point into focus. Whether you ever change custom settings A2 or A1 depends upon your subjects and your style of shooting. Consider your goals and whether changing these settings will help you take better photos. To begin using live view, turn the drive dial to LV. Press the shutter release to activate live view on the LCD monitor. Live view looks a lot like the screen view you get on point-and-shoot cameras. It is a useful feature for shooting at awkward or low angles or when taking extreme close-ups. You have two focusing options for live view under the shooting menu. One is called handheld and the other is tripod. In handheld mode, the camera employs phase detection autofocus. This is the same focusing procedure the camera uses in regular shooting modes. Initiate autofocus by pressing AF on or by pressing the shutter release halfway. Phase detection is a very fast way to focus. The camera can accurately focus on a subject, but may not focus on precisely the same spot in every shot. For this reason, phase detection is not the best choice for extreme macro photography. Instead, phase detection works best on moving subjects or when the camera is handheld. The autofocus system is fast enough to keep up with any small movements the subject or the camera might make. When you shoot in handheld mode, the reflex mirror will click into place during focusing. The LCD monitor will go black and the picture will not return until you take your finger off the shutter button. The camera uses the focus sensors and prisms in the top of the viewfinder to quickly calculate whether the image is in focus behind the selected focus area. In tripod mode, the camera employs contrast detection autofocus. This system offers accuracy and precision because it sets the focus by comparing two adjacent pixels for contrast. The greater the contrast between the pixels, the more accurate the focus. Contrast detection autofocus takes more time than phase detection, so it is most appropriate to macro photography and for shooting stationary subjects from a tripod. You can magnify the scene up to 13 times its normal size and use the multi-selector to choose a focus point. Press AF on to focus. If the camera can't achieve focus, the focus point will blink red. If you're shooting macro subjects in tripod mode, consider activating custom setting D9. This will delay the shutter release by 1 second, which will prevent any accidental movement caused by pressing the shutter release. One final note, if you use live view, you'll also want to configure the release mode option. Your choices are single frame, continuous low speed, and continuous high speed. Let's take a look at focus tracking with lock on. You can configure this under custom setting A4. Focus tracking with lock on tells the camera how long to wait before refocusing when another object briefly gets in the way of your subject. This video is a great example. When the trees block the view of this giraffe, focus tracking with lock on will keep the camera from refocusing on the trees. There's been some discussion among Nikon users as to whether lock on is a good idea. Some photographers have chosen to turn it off rather than keep it on the default setting of normal. In truth, there are a few situations in which lock on could get in the way. While shooting macro images of an insect, a photographer may turn off this function in order to cut out any lag time between pressing the shutter button and the actual shutter release. He knows there is little chance that an unforeseen object will throw off the focus, but he also knows the insect could make an abrupt movement. With A4 turned off, the photographer can be certain the camera will refocus immediately. There are also advantages to keeping A4 turned on.
The A4 custom setting is actually a really nice feature because if you're shooting something like a football game or a soccer game and you have a lot of subject matter moving in your foreground, it won't ping pong the focus back and forth. It's going to stay focused on what's in the background where you want your focus to be. It's like if you're driving down the street, shooting out the side of your car and telephone poles start coming by you, it won't jump focus to the foreground. It's always going to stay on the background, and you can set that in 3 different modes for how long you want that focus to track.
This next series of custom settings can be used in setting a correct exposure, but only in limited situations. For example, with custom setting B6, you can set the camera to consistently under or overexpose the image by up to 1 stop in 1/6 EV steps. You can do this for each metering method.
The B6 custom setting is an area where I might make an adjustment if I start shooting with my new camera and I'm going into Photoshop and I'm adjusting my files and I consistently see that maybe my images are a little too dark or a little too bright, and my personal preference is that I want to change that within the metering system. So I can go in, make that adjustment, and then I get the results I want every time I go through my system from shooting to post to output.
In essence, you are recalibrating the light meter. This setting is not exposure compensation, so the plus-minus icon will not appear in any of the camera displays. If you want to use exposure compensation, you will still need to press the button and turn the main command dial. The camera will apply exposure compensation on top of the optimal exposure fine-tuning. If you want to cancel B6, you will need to reset the custom settings bank. Custom settings E1 and E2 allow you to determine the shutter speed and sync speed when shooting with a flash. When you turn on the flash, the camera will usually lock in 1/250th of a second as the fastest possible shutter speed. However, custom setting E1 allows you to set the shutter speed at 1/320th of a second or even higher when working with external Nikon speedlights. You can also use E1 to lock in a slower shutter speed as the upper limit. This can be especially helpful when you're shooting indoors and want to pick up some ambient light along with the flash.
E1 is a setting where you can adjust the shutter speed from, say, 2/50th down. You could say, I only want this to shoot at an 80th of a second with the flash. And the time that I would use this is potentially in an environment where the ambient was at a certain level that I wanted to maintain in the background. So you can just do a test without the flash, see what you want the ambient exposure to be, say it's an 80th of a second, then set that into your camera so that no matter where you're shooting for the rest of the night, you're gathering the ambient light that you want at the desired level, and then your flash is filling in appropriately.
Custom setting E2 allows you to change the slower limit for shutter speeds in front or rear curtain sync when the camera is set to programmed auto or aperture priority. This also applies to the red-eye reduction mode. The default is 1/60th of a second. When you're shooting in programmed auto or aperture priority mode, it is assumed that you will be working without a tripod. In these cases, 1/60th of a second is the slowest shutter speed you can use with flash sync and still avoid blur. At this speed, the background may remain dark, but the flash will expose the subject properly.
E2 is a custom setting that's built in a little bit for safety for new camera users. If you're shooting, it's basically telling you in either aperture priority or in program mode that it won't let you shoot below 1/60th of a second. And the main reason for that is that it wants you to get pictures that are relatively sharp, and it's shutting you down at that point and saying, whoa, warning, you can't shoot here because you're going to start to probably get some motion.
However, with the improving technology and falling prices of vibration reduction lenses, many photographers want the option to shoot at slower shutter speeds. VR lenses allow you to shoot at up to 3 stops slower than with regular lenses. So, for example, if you are using a 50mm lens to shoot flash photos at a party, you might expect to need the default setting of 1/60th to get a clean image. But VR technology allows you to shoot 3 stops slower, which would mean a shutter speed of 1/8 of a second. In the resulting image, the background won't be quite as dark as it was at 1/60th of a second. So, if you are shooting with a flash and have a VR lens, consider using E2 to allow the shutter to stay open longer. The camera will collect enough ambient light to get the shot you want without the problem of blur. Custom setting E4 engages the modeling flash, which can help you check your composition when working with one or several flashes. When you press the preview button with the flash raised, the flash will emit a continuous burst of light for about 1 second. If the camera is controlling external flashes, these units will also emit a modeling light.
As a professional in the studio, I'm working with strobes that have a tungsten modeling light, a consistent light source so I can see the effects of my light prior to the flash going off. The same thing is true with what Nikon's put into their speed lights for the creative lighting system. And you can either set this function so it'll either be on or off. The reason why you would want to use this with one or multiple flashes is to get a preview of roughly what your lighting's going to look like.
If the shadows look too harsh or they fall in the wrong place, you can simply rearrange them before taking your shot. 2 points to consider about the modeling flash. First, it can use up a great deal of your battery power, so use the modeling flash sparingly. Second, it will not turn on if you have reprogrammed the preview button in the custom settings menu. Make certain that this option is on the default setting of preview. Custom setting E5 allows you to quickly check your flash setting through bracketing. Begin by setting the camera to bracket the flash only under E5. The camera will boost or reduce the flash value over the next several shots you take. This is a quick way to determine how much flash you need to light your subject. Best of all, you can use this setting when shooting with multiple speedlights in commander mode. Bracketing can be a handy shortcut anytime you use the flash. Custom setting E6 is for bracketing with the flash in manual mode. You can set up the camera to bracket the shutter speed, aperture, both, or the flash alone.
We used to do that all the time when you were shooting slide film in a situation where the light was going, or maybe you had a subject matter that you had very limited time with, and you're basically just covering your tail. You're just pushing the button and you're getting it exposed every way you can, so when you get your film back from the lab, you had the picture. With digital, I don't really have a use for that. Maybe there's a situation where I say, I want to see what the flash is at 1 and -1/2, so I could set my flash up so it'll shoot both of those simultaneously. Or if you're doing high dynamic range photography, you may be in a situation where you want to set your camera up to bracket so you'll get an underexposure, a normal exposure, and an overexposure, and you can put those together in the computer after the fact.
One quick note. Nikon has eliminated the bracketing button in more recent generations of its DSLR cameras. Instead, auto bracketing is the default option for the function button. If you have already used the custom settings to reprogram the function button, You will need to access Assign Function button and then the Function button plus Dial menu to return it to auto bracketing. Now, when you press the Function button and turn the main command dial, you can choose the number of shots you want to bracket. The camera will add bracket indicators to the analog exposure meters on all of the shooting displays. If you press the Function button and turn the sub-command dial, you can set the exposure increment from 1/3 to 1 full EV step. When you take bracketed photos, the camera will normally take the first shot at the metered setting, then the underexposed images, followed by overexposed images. You can change the bracketing order under custom setting E7, so the camera will take the underexposed images first, then the metered setting, and finally the overexposed images.
A gray card is like my measuring stick. It's what gets me back to square one no matter where I'm at. So I always have a digital gray card in my camera bag, whether I'm shooting in the studio, on location, and it's something we always stick into the frame, so when we get back to the studio, we can always color balance and neutralize the image based on that gray card, so our images have consistent results all the time.
This is a gray card. It's made from cardboard and has a matte surface. Sometimes the back will be white, which you can use for white balancing. This color is called 18% gray, which means it reflects 18% of the light that falls upon it. Many pros feel that a gray card is critical to properly metering the light. If you aren't clear on the basics of metering, you will want to watch the introductory DVD for your camera. The metering section includes an experiment that will help you better understand what happens when the camera meters light. This camera offers 3 metering options: matrix, center weighted, and spot. If there is a high level of contrast between your subject and the background, or if it's lit by multiple sources, or if your subject is backlit, try spot metering on something in the scene that has a mid-tone value. This will help ensure that your subject is properly exposed. But for more consistent results, you need to use a gray card. Place your card in the scene, making sure it's illuminated by your light sources, and spot meter on the card.
One of the great things about a gray card is you can batch process a lot of your images. If you have it into one scene with one lighting condition, we can take all the images into Photoshop, batch process all the images, and adjust the color to that gray card so that all the images we photographed in that lighting situation are neutralized at one time.
Just make sure your gray card is lit with the same light sources as your subject. Otherwise, you'll end up with an incorrect exposure. Also, be sure you have the right kind of gray card.
Yeah, if you have a gray card that you've been shooting with for years, you might want to look into a digital gray card. I know there's a little bit of a difference between the two with the reflective and the tonal qualities of them. We bought a new one recently at our camera store, and we buy little small ones that we can keep in every camera bag, so we have one with us all the time.
Make these reference photos a part of your routine and use the card, when necessary, as a metering tool. For just a few dollars, you can save yourself a great deal of work and frustration. Many photographers are reluctant to try manual exposure mode. Some find this setting to be intimidating. Others simply don't see the point of using it, especially when they can use shutter priority or aperture priority instead. As you recall, these modes allow you to select a shutter speed or aperture value, and then the camera chooses the right settings for a correct exposure. To obtain an under or overexposed shot, you need to engage exposure compensation. We want you to think of manual mode as the next logical step in controlling the exposure. Manual is like activating aperture priority mode, shutter priority mode, and exposure compensation all at once. Consider using manual anytime you know you're going to deviate from the metered settings. Take this image as an example. There is an infinite depth of field, so everything is in focus, from the waves to the distant coastline. The shot is also underexposed, which creates the impression that darkness is just about to fall. Had the photographer taken this image in aperture priority mode, he may not have gotten the same results. In these conditions, with an aperture value at f16, the camera would have automatically set a slower shutter speed. The image is now correctly exposed, but it doesn't have the same feel as the first version. By shooting in manual mode, the photographer was able to set the aperture value at f/16 and then set a shutter speed of 1/250th of a second. The image is underexposed by a full EV step. If the photographer doesn't like the results, it's easy to make minute changes and create the image he originally had in mind. To set the aperture in manual mode, turn the sub-command dial. The main command dial controls the shutter. We encourage you to try shooting in manual mode. After a while, you may find it to be just as intuitive as shooting in one of the priority auto modes. If you edit a lot of images on the computer, you may have already considered the idea of shooting in RAW. This format allows you to transfer the maximum original image data to your computer and then apply white balance, picture controls, and other settings as you like. The NEF RAW recording option in the shooting menu allows you to select the bit depth for your RAW images, either the standard 12 bits or the newer 14 bits. What is the difference between these settings? To the casual observer, the only obvious difference is that 14-bit files are larger and can have a slower frame rate. But the real difference between 12 and 14-bit depths is the larger setting allows for greater color depth and more details in the shadows than 12-bit images. As an example, look at these two low-light images. When viewed at 100%, they look the same. However, were you to enlarge these images and take a close look into the shadows, you would see much more detail in the photo taken at 14 bits than the 12-bit image. The 14-bit image only has 2 more bits, but the amount of data the camera can record at 14 is exponentially larger than at 12 bits. As a result, the camera is able to record more of the contrast between light and dark at the lowest end of the brightness spectrum. The 14-bit depth also allows you to record the truest colors. It may be most evident in images that contain a gradation of colors, such as this sunset. The 12-bit RAW recording does a really good job of reproducing the smooth transition from orange to rust. However, 14 bits offer more discrete color values, meaning the gradient will appear even smoother, especially when blown up to a larger size. When shooting product photos or magazine spreads, where the colors have to be exact, the 14-bit depth simply gives you more color precision.
There's a lot of questions, what do I shoot in? My question is typically, how are you going to output your pictures? When you think about your output, you need to think about the size of the output, whether it's going to be a billboard, maybe a web page, full page in a magazine, a double truck, to understand how big that file really needs to be. Is your final image going to be output this big, or is it going to be this big, or is it going to be a poster? The difference between 12 and 14-bit for a lot of people is going to be, fairly unnoticeable. But if I'm shooting a billboard for a national ad campaign, I want as much color, as much information, the best file I can get. Because if your file is too small and your bit depth is too low, when you go to print out your results, you're going to be disappointed. Just the other day I had a neighbor say, "Hey Tim, I just did this photo shoot and I shot in RAW and I did an online order of a poster and it came back and it's really soft and I'm disappointed with the results." Well, I said, "Well, how big of a file did you send?" It doesn't matter if you shoot it in 14-bit RAW and you convert it and you have a 40 or 50 meg file if you're only uploading a 5 meg file that your poster is being made from. So it's really important to know what is the output that you're going to and how big of a file do they need to appropriately print that. A lot of online services aren't even going to allow you to send a file of that size, so if you want to go big, you might be better off to go to a local lab, take in the CD or the DVD and have them print it.
To allow for smaller files, the camera offers RAW compression that has very little effect on image quality. Under the NEF RAW recording option, select one type of recording, either lossless compressed, compressed, or uncompressed. Lossless compressed will reduce the RAW file size by up to 40% without any effect on image quality. Compressed will cut down the file size by up to 55%. The effect to image quality is negligible. The trade-off here is that recording compressed files takes a little longer than recording uncompressed raw files. As a result, images may take longer to clear the buffer. Keep this in mind if maintaining your frame speed is more important to you than saving space on your memory card. The D300 and D700 allow you to take series of pictures over long intervals of time. You can view these images separately or assemble them in a video as we've shown here. Choose Interval Timer Shooting under the Shooting menu to set up this feature. You can select the start time, the interval between exposures, and the total number of shots. Use a tripod for best results, and remember to attach the eyepiece cover. With the D700, simply use the viewfinder cover switch. It is important to remember that the camera automatically focuses before each shot. Most of the time, that's okay, but this also means the focus could get thrown off if anything temporarily blocks the view of the subject. The solution is to focus on the subject and turn the focus mode to manual before starting the interval timer. Custom setting D9 can help you get steady shots under less than perfect circumstances. In the D300 introductory DVD, we suggested setting the 2-second timer when shooting from a tripod. The reason was that sometimes new photographers just don't have the cash to buy a quality tripod after spending all that money on the camera body and a lens. Using a timer will make up for any shakiness from your tripod. One problem with this solution is it prevents you from shooting in live view, and anytime you want to take a self-portrait, you will have to reset the timer countdown. So, if you take most of your images from a tripod, turn on custom setting D9. This setting makes the camera wait 1 second after you press the shutter button before actually releasing the shutter.
D9 is a nice feature, and if you're shooting on a tripod with a long exposure, you can set that instead of your timer so you can get your hands off the camera. A lot of people, when they first start in photography, don't realize just how sensitive that camera can be with movement. So if you don't have a delay in your shutter and you just push the button with your hand on it, you can get a little bit of movement.
Also consider enabling D9 whenever you use a large zoom lens. The lens could make your camera front heavy on the tripod. Custom setting D9 will cut down on any possible camera shake. This all being said, the better solution to camera shake is simply to buy a sturdy, good quality tripod. After all, you invested a lot of money in your camera and lenses. Why would you risk placing them on a low quality tripod? On this camera, you can change the operations of 5 buttons: Function, Depth of Field Preview, AE Lock, the Multi-Selector Center button, and the Shutter Release. The great advantage of programmability is that you can move camera functions around to better suit your shooting style and abilities. For example, after working with the camera for a while, you may find it's helpful to have AE Lock and AF Lock separated. One solution you could try is AE Lock Hold. This setting will remove focus lock from the AE Lock button. At the same time, it allows you to lock the exposure and keep it locked until the exposure meter turns off or you press AE Lock again. This option is especially useful when shooting a moving subject. Engage the AE Lock Hold at the beginning of your shoot. AE Lock Hold will ensure that every image has the same exposure. Now you are free to focus on your subject and refocus as needed without having to worry about a bad exposure. Another option is to turn the AE Lock button into a temporary meter button. This is very useful if you shoot most of your images in one metering mode, such as 3D Matrix, but also occasionally need spot or center-weighted metering. Rather than turning the metering dial, you can program the camera so it will switch to spot or center-weighted metering whenever you press and hold the AE Lock button. Alternatively, you could program either the Function or Preview button to act as a meter button. For flash photography in high-contrast situations or tricky lighting, you may want to assign Flash Value Lock to one of the programmable buttons. In the same way we use AE Lock to correctly meter a subject and lock in the settings, we can use Flash Value Lock to set the flash level before we take the shot. You can use flash value lock with a built-in flash and external flash, or a group of speedlights being controlled remotely by the camera. This function will help ensure that you get the correct exposure for high contrast subjects or when the scene contains reflective surfaces, such as mirrors. Focus on your subject in the center of the frame. While pressing the shutter release halfway, push FV lock, and the speedlights will fire without taking a photo. If you are only using the built-in flash, the camera will spot meter on your subject, but with multiple flash units, the camera will meter the entire frame. Now, reframe your subject and take the shot. The results will show a correctly exposed subject with an under- or overexposed background. Consider using FV lock when taking portraits in a studio setting. With the regular flash setting, the camera will fire a pre-flash that could make your subject blink. Locking the flash level in advance also disables the pre-flash. If you decide to reprogram the AE lock button, you'll need to find a new location for the exposure lock. You could reassign this function to the function button or the preview button, but then you will lose some of the camera's flexibility. Instead, select On from Custom Settings C1 and move AE lock to the shutter release. Many photographers find it more natural to have exposure lock in the shutter release. Here's the best part. Custom Setting A5 allows you to move autofocus activation exclusively to the AF On button. With this configuration, you may find it easier to shoot subjects in unpredictable lighting, such as this filtered sunlight. If the subject isn't moving too much, you can set the focus early using AF On. When you press the shutter release, the camera will meter at that instant and set a correct exposure. You may find that using the shutter release and AF On button together in this way is more comfortable than the camera's default setup. At Blue Crane Digital, we switch back and forth between Nikon and Canon cameras all the time, so we are well aware that trading one camera for the other can lead to frustration and confusion. The reality is, when you're used to one brand of camera, switching to a different brand feels awkward. If you happen to be moving from a Canon to a Nikon, consider trying some of the following custom settings. They may help make the camera seem more intuitive. For example, one of the more obvious differences between the Canon and the Nikon is the direction of the exposure meter. Nikon users are accustomed to seeing lines to the left when they increase the exposure and lines to the right when they decrease the exposure. It is the opposite for Canon users. The plus side is on the right and the minus is on the left. This can lead to exposure problems for photographers who use both camera brands. To avoid any confusion, you could use the reverse indicators custom setting to flip the exposure meter. Now the plus side is on the right. Another custom setting to consider is B4. With easy exposure compensation, you won't need to press this button to activate the exposure meter. Instead, you just rotate the command dial. This action corresponds to the turning of the quick control dial on the Canon. There are no buttons to push first. So long as the dial is activated, exposure compensation is just a few turns away. Finally, you may want to customize the command and subcommand dials. The menu and playback option activates the main command dial in both the menu system and during image playback. Usually, you would need to press the multi-selector left and right arrows to move through images in playback mode. With this setting, you can also use the main command dial just as you would use the quick control dial on a Canon. Switch over to the menu system, and you can use the main command dial to move the menu bar up and down. On a Canon, it's the quick control dial that takes you down into the menu system. Maybe you have never used another brand of camera. Even so, we encourage you to check out these and all of the custom settings before you dismiss them. If any one of them makes the camera more intuitive to you, then you have an even better chance of getting great shots.
Reprogram the outside buttons of the camera is really an amazing feature that the D300 offers. However, don't feel like you have to use this just because it's there. You may get into a personal situation where you say, I would be great if I could turn the depth of field preview into a spot metering button, and you can go ahead and program it that way. But again, find a need that fits for what you want. Don't feel like you have to use them because they're there.
The latest generations of Nikons offer an improved commander mode with more channels, more groups, and more options than in previous generations of Nikon DSLR cameras. For those unfamiliar with commander mode, it is a master wireless controller that allows you to run one or several external flashes remotely. This chapter does not offer a comprehensive tutorial for using Nikon speedlights. Instead, we will demonstrate what is possible with the hope that it will excite you enough to explore creative lighting on your own. While the built-in speedlight is good in a pinch, it really doesn't have the size or power to give you the best flash results. The light can be harsh. If you use the flash from a distance of several inches or more, you will see a stark contrast between light and shadow on your subject. Another problem with the built-in flash is that it sits directly over and perpendicular to the focal plane. This angle can result in an image that looks flat. If you can move the flash unit off axis, even at arm's length, the results will look much better.
So we're going to take a look at the different lighting effects from using a hard light, much like your on-camera flash from directly behind the camera. What you can see is with this small light source at this distance on the subject matter, you can see the harsh shadows that we're getting falling onto the background. You can see the hot specular highlights in the glass and on the metal of the truck. So much like an on-camera flash, this is the kind of look that you're going to get. You'll see if we just take that light and we walk it around and put it just off camera, already we're starting to improve the look of our image because the shadows are falling to the side and it's more natural and indicative of what you would see out in sunlight outdoors. If you want to soften that up, you can take a diffusion panel and you can put that over the top of the light source. And again, it's relative to the size of the light source to the subject. So from this distance, the light source is only the size of the area spilling onto the panel. So you can see that we've definitely increased the size of the specular highlights. They're a little softer, a little more natural window light. And if we start to walk this in, look at what's happening to the size of this panel. It's growing, it's growing, it's growing. And now as we get it right up close to the subject matter, you can see that the highlights on the glass have almost disappeared. We can now see right through the speculars, see what's inside the jar, and we get nice soft window light on our subject. You can't go wrong doing a portrait of somebody with a big soft window light, and I use this kind of lighting source all the time to shoot portraits of people.
Our next demonstration will require some equipment. Not a lot, but enough to explain how commander mode on the D300 can improve the quality of your photography. First, let's walk through the settings. In custom setting E3, you can choose to have the built-in flash operate in commander mode. Press the right arrow key on the multi-selector to choose this option. On the bottom of the next screen, there is a selection for channel. You would really only need this option when shooting a common subject with other Nikon photographers who are also shooting in commander mode. In most situations, you can just leave this on channel 1. Be sure to set all your remote speedlights to channel 1 as well. Then forget about it. Next, let's look at the built-in flash settings. If you change this to TTL and leave the flash compensation at 0, the results will be the same as if you just raised the pop-up flash and took the shot. Instead, turn the built-in flash option to the double line setting. This prevents the pop-up flash from firing when you take the shot. Leave the flash extended because you will need it to trigger the external flashes. To prepare the external speedlight, again, set the channel to 1 and change the group to A. In the commander mode menu, change the group A to TTL, which means the camera will take measurements through the lens to determine the amount of flash needed. Also, make sure that the flash compensation is set to 0. Now you can place the flash unit wherever you like, and the metering system inside the camera will calculate the correct flash value. In the following portrait demonstration, Tim uses these commander mode settings while also applying the concepts of hard and soft lighting.
The first thing we're going to do is take an ambient exposure of just Katya with the studio house lights on. Great, hold still right there. So you'll see the lighting here is going to be warm and not really flattering because it's a tungsten light source. We have the camera set on daylight, and it just overall has kind of a harsh look. I'm going to turn the speed light on top of the camera here, and we're going to set the camera into manual mode. And I'm going to choose manual mode so I have control over the camera settings and can get exactly what I want. I'm going to pick an aperture of f/5.6 and a shutter speed of 1/60th of a second with the camera speed light in TTL mode. And I'm going to take another shot. Good, right there. You'll see here the lighting is pretty harsh. Slight shadow falling off to the side because we have the camera in the vertical position here. Let me take another one there. Good. All right, I'm not too pleased with this lighting, so what we're going to do is move the speed light off of the camera using the offshoe accessory cord. So I've added an accessory cord for the speed light. If you just go to your local camera store and tell them you want to get a off-camera cord, they'll be able to help you out depending on the specific speed light you have. And what this is going to allow me to do is still shoot in TTL mode and get the light source off axis, be a little more flattering. Great. It's still going to be pretty specular because it's a small light source from far away. We'll take a look here, see if we can kind of get the shadows to fall in a better position. I'm going to move this even a little bit more off to the side. That's great. Looking right here, a little smile. Okay, this source is still a little too specular for me, so I'm going to stretch this light off the side just a little bit further here. This is going to give us a look more like natural sunlight. It's not going to be so harsh right behind camera. Good little look right here. 1, 2, and 3. Great. A little smile right there. Good. And looking at this, I mean, it's definitely looking a lot better. You may like this quality of light. For me, I want to soften it up a little bit, so there's a couple things I can do. The next thing I'm going to do is add a small softbox to the speed light. So I've attached a small softbox onto the face of the speed light. This is going to slightly increase the size of that light source relative to our subject. I'm going to recompose and take another shot. Great, looking right here. Good, little smile. Still just a little too harsh for my liking in this situation. This is a great light source if you're shooting photojournalism outside, maybe at a party or a wedding reception, and you want to, soften the shadows up a little bit. But for a portrait, I like to work with bigger light sources, so I'm going to float a panel in here and make that light source even larger. So now we've added a diffusion panel. This is something you can get at your local camera store for about 80 bucks. If you don't want to spend the money, you can try it with a bed sheet. You can bounce the strobe off a wall to get a similar effect. But basically, you're increasing the size of the light source. No longer is the speed light our actual light source. The panel has become our light source. So relative to Katya, the light source is now much larger. We take this picture here. We're going to get a nice soft window light look. Good little smile. Roll your head this way just a little bit. Great. A little grin. One of the great things about the Nikon D300 is their creative lighting system using the speed lights in commander mode. For this first shot, I've got my on-camera flash popped up, and I have my speed light in commander mode, and it's group A.
In the default setting, the built-in speed light fires along with the external speed light. The results will not look as pleasing as they would if the built-in flash was turned off. In this section, Tim will demonstrate how turning off one light will make a difference. Again, he has the speed light set to channel 1 and group A. The camera is also set in commander mode to channel 1 and group A. First, Tim will set the built-in flash to TTL, which means it will fire with the external speed light when he takes the first shot. Then, Tim will change the built-in flash setting to the double line and rely only on the external speed light.
So basically what I'm going to get here is I'm going to do 2 shots. I'm going to take the first one with the on-camera flash firing and with the speed light firing through the silk. The beep reminds me that the flash is recycled. Looking at this shot, you'll see the effects of the fill flash from the camera. Second, I'm going to go into commander mode and I'm going to turn the on-camera flash off. Currently it was in TTL. I'm going to toggle down to off and hit OK. So now the only light that's going to fire is the speed light. Great, little smile there. Very nice. And I can control the power of this light from the camera, and it's a great habit to get into to work off of the camera body, because if you start working off of the flash heads and the camera body independently, you're going to get confused with where your settings are at.
Next, Tim adds more equipment to the shoot. The second speed light will illuminate the head and shoulders of the model from the back to separate her from the background. Just as before, Tim will select Channel 1. If he also selects Group A, then this speed light will emit the same amount of light as the other flash. Instead, he selects Group B. On the camera, he programs Group B to manual and dials down to the lowest possible flash power, which is 1/128th of full power.
So I've added another speed light for this setup as a hair light up behind the background. So right now we're working with two speed lights. The first one is the main light, which is going to go through the silk, giving a nice soft light on Katya, and the second is a hair light coming from behind. We're working in commander mode with two groups. Group 1 is the main light, and group 2 is the background light. The reason why I have it set up this way is the main light is set on TTL, which is going to give me the normal exposure that I want, and the background light I've set into manual mode so I can independently control that edge light from camera. It's up high on a stand, so instead of me getting on a ladder and making adjustments to it, I can command everything right off the back of the camera. So I'm going to take a look at my exposure now. That's starting to look really nice. Great, and I'm going to kick on a little wind and start shooting. Great, right there. Nice. Good, little smile from there. Perfect. Good, big grin. Looking great. And although you may not have all these tools to your disposal like I do here in the studio, the main thing is that these are all principles that apply to your photography no matter where you're shooting.
Finally, we will take these lighting concepts a step further and demonstrate an environmental portrait. For this setup, Tim uses the commander mode to control a speed light that's inside a softbox. Instead of adding a second speed light as a hair light, Tim uses the setting sun to add depth to the scene. Also notice that Tim is shooting from a low angle. He underexposes the sky, making it look more saturated. The overall effect is very dramatic.
Keep walking it this way. Stop. Okay, back it out now. Back, 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 back. Great, right there. Out just a little bit more. Super. Okay, here we go. Great, looking right here. Good. I'm going to turn this into single mode. Great. Looking right here. A little smile. Kind of happy about this whole thing. Yeah, it looks nice. Great. Good shot. Here we go again. 1, 2, and 3. Okay, now let's see that serious game face.
It's hard to be serious when you say be serious.
Yeah. That's good. You're doing great. Right there. Perfect. Right there. 1, 2, and 3. Crop in just a little tighter. Sky's looking really nice. Great. Perfect. Little grin. Good. Nose that way just a touch. Super right here. Yeah, nice.
Great, right there. Turn away from me just a little bit, Eric. There you go. Good. Nose that way just a touch. And then chin out just a little. I'm shooting at kind of a low angle. So yeah, that's good. If it feels wrong, you're doing it right. Super. Right here. Good. Looking off that way. Just kind of off into the wild blue yonder. Good. That looks great. Good. One more right here. Good. Eyes right here. Yep. Perfect. Gonna get low.
The color settings in the D300 appear to be deceptively simple. Just dial in auto white balance, take the picture, and you're good to go, right? Unfortunately, the real world presents us with a variety of light sources, each with its own Kelvin temperature. Different types of light sources also vary in how true the color looks when reflected back to the viewer. In this case, the viewer is the image sensor. In addition, your camera allows you to set up picture controls that affect how color is processed in the camera and gives you a choice of color space. Last but not least, your images will not live in your camera. They may be printed either on a personal printer or on a press. They may be posted on the web to be viewed with either a color-managed browser or an application that discards your color space for a generic standard. If you need a refresher, go to the Additional Materials section of this DVD and select the chapter entitled D300 White Balance. This is the same material found in the Introduction DVD. Once you're finished watching it, select the Chapters tab and select the chapter named Understanding Color 2. Following these steps will return you to this point in the presentation. Let's consider the camera's Kelvin temperature settings. If you know the color temperature of your light source, then select the Kelvin temperature option in white balance mode and set an appropriate value. In this case, the light source has a blue cast because the sky is overcast. The camera, set to 6250 kelvins, will push the colors toward amber. The result will be an image that replicates the colors on a sunny day in the early afternoon. If the light is more amber and the K setting matches the actual conditions, then the camera's processor will push the colors toward the blue end of the spectrum, again to replicate daylight colors at midday. To better understand Kelvin temperatures, try this experiment. Go outside, pick a subject to photograph, and put a gray card in the scene. As we mentioned earlier, a neutral gray card represents a midtone value. This is also called 18% gray. You can use this card not only in metering, but as a reference point for correcting the white balance. Select the Kelvin temperature option under white balance and set the camera to 2500 kelvins. Now, take a photo of your subject and gray card. Repeat with each Kelvin value. Load the images into an image processing program, such as Photoshop. Here we will be able to use the gray card as the basis for white balance corrections. But first, we'll look at the gray card in each shot and find out how much it deviates from true gray. Display the info palette and then select the eyedropper. Click on the gray card and check the red, green, blue values listed on the info palette. All three values should be the same. If they aren't, then the values will tell you which colors need to be adjusted to correct the white balance. Test the gray card from each shot to see how color temperature affected the image. Next, we will show you how to correct the white balance in a photo based on a gray card. Most professional photographers begin their photo shoots by placing a gray card in the scene where it can reflect the light source. Then they take a reference photo. They use this reference shot in Photoshop to correct the white balance in a group of images. Here's how it works. Go to the Image drop-down menu and click on Adjustments. Select Curves or Levels, either of which will give you a gray eyedropper you can use to test the gray card. Click OK. That's it. Your image is now color corrected for the existing light source when you took the photo. If you save this change in a Photoshop action, you can later color correct a batch of images shot under the same conditions. Sometimes you may wish to create a specific look and apply it to a group of similar photos. You might think the best way to accomplish this is in your photo editing program with a tool like batch processing. Create a specific look in your camera instead, and you can save a significant amount of time. Think of the camera's picture control settings a little bit like film stock. In the old days, you would select a specific type of film stock based on your knowledge of how the emulsions would perform with specific subjects and lighting. Today, many photographers use digital cameras and processing software to create the look they want. But after spending hours with Photoshop applying the same changes to your images over and over again, you may see the value in having some of those stylistic choices programmed into your camera. This can be especially useful if you are a professional and your client is reviewing your work on the spot. By creating a custom curve and other controls, you can more closely emulate the finished product. Your client won't need to imagine how the final product will look. He can see it right in the camera. If you are shooting portraits, you might want to create a soft look. Use picture controls to reduce the image sharpness and saturation for a more pastel effect. You could also create picture controls with varying hues to better complement different skin tones. Best of all, you can save 9 of these settings on your camera and even more on a memory card. You can have an entire catalog of looks right at your fingertips. Or perhaps you like shooting black and white photos of landscapes, flowers, and insects. You might build a monochrome setting with a red filter for green vistas, then also create a setting with enhanced saturation and sharpening for the macro shots of insects. Both the View NX and Capture NX programs offer a picture control utility that allows you to create your own picture controls. You can save the settings on your computer and apply them to images or download the custom controls to your camera. Begin by opening an NEF file. From View NX, launch the picture control utility from the File drop-down menu. Or in Capture NX, go to the Edit list and go down to Picture Control. To launch the utility, click on the cogged wheel icon near the top of the picture control box. You can either use the sample image or build a new picture control from one of your saved images. Now click the New button, give the file a name, and begin creating your custom picture control. Use the sliders to set the contrast and brightness, or click on Use Custom Curve to create a gamma curve on the graph below. You can also set your own sharpening, saturation, and hue. When you've finished making changes, click the Save tab and save the curves file to your computer. Now export the custom picture control to a CF memory card. You can store up to 99 picture controls on your memory card. You can load up to 9 into the user-defined spaces in the camera. Store the card in your camera bag, and you will always have your picture controls library when you need it. If you shoot in RAW, you can use picture controls within Capture NX during post-processing. With this approach, you can develop a specific look, then apply that look to your entire photo session using Capture NX's batch utilities.
A time when picture controls might be very useful is, let's say you have a client, you're out on location, and you know that this person likes every image desaturated by 20%. That's the look of this campaign. Or if you're a wedding photographer and you want to switch everything to sepia or black and white, you can do that on the fly. It's a way basically you can make kind of your own film emulsion, get the look you want, and then program it into the camera so when you put it into that setting, every time you shoot you get that specific look and you don't have to worry about manipulating it after the fact to have a consistent look that you like. You can do it on the fly and see as you're shooting what that result is going to look like.
Just as you can approximate a color correction filter using the white balance options, you can also set the camera to add contrast enhancement to monochrome images. In the black and white film days, photographers would use red, yellow, orange, or green filters to enhance certain tones in their photos. For example, while shooting portraits, a photographer might use a green filter to soften skin tones, or for landscapes use a yellow filter to make white clouds stand out against the sky. The actual color of the filter does not appear in the resulting image. So how does it affect a black and white photo? Monochrome images are made up of a wide range of grays from very dark to very light. The color filter helps differentiate between color tones that would otherwise look the same when represented in black and white. The resulting image will have a greater variety of distinct gray values. The rule of thumb is, colored filters lighten anything that is the same color as the filter and darken all complementary colors. For example, here is a red filter. We will place it in front of a multicolored object under white incandescent light. Look at the results. The red areas of the object appear lighter because the red band of the light spectrum can pass through the filter. All the other colors are blocked. Anything on the object that has red tones appears to be a lighter color than the rest. The green segments look very dark. The filter isn't allowing much light to illuminate the green areas, so they are dark. To approximate this effect with your digital camera, select Set Picture Controls from the shooting menu and go to Monochrome. Use the multi-selector to access the monochrome menu. Toggle down to Filter Effects. For this example, we will select O for orange. If you'd like, you can also change the image sharpening, contrast, and brightness from this menu. The last option is toning, which adds tints such as sepia to your images. Test out Nikon's monochrome settings. You may find there are times when a black and white image has more impact than one with color. If you've ever struggled with getting prints to match the shot on the camera back, or JPEG files to look like the original subject, you've been affected by one of the real challenges in digital imaging technology. Your images don't live in your camera. They travel through a series of devices such as your computer and printer before they're viewed by your intended audience. These devices don't handle color in a simple, standardized way. This next section is about color management. It's packed with information, but still barely begins to touch on this complex subject. We present it as an introduction to color management, so you can begin protecting the beautiful images you've captured.
Hi, my name is Mark Aguilera, and I am co-founder and color management director of Encompass. Encompass is a group of professionals who dedicate their time to design, interactive, and color management solutions. What I want to talk to you today about is, what is color? How do you define color? Color is your individual experience of light and object. It's your experience. It's something that happens to you as the observer. So what components are there to color? There's light, there's daylight, there's incandescent light, there's fluorescent light. There's the observer, different observers like myself and yourself, and there's different objects like the printed paper, the monitor, the real world. Now let's talk about digital color. Digital color is a little bit different because we've got RGB, red, green, blue. Digital color is based on light, purely based on light. Our monitors are based on red, green, and blue. RGB is additive, which means when light adds, you get different color. This is different than object-based color or print-based color. Print-based color is based upon subtractive light. Light hits an object, you subtract that light, and the rest comes back to the eye to experience cyan or experience red. So for instance, if you have a cyan blob of ink on paper, what's going on? Well, cyan absorbs red energy, wavelength energy, and reflects green and blue. So when we think about color, we have to know that, one, there's the individual experience, and two, that we're dealing with the world of RGB when it comes to monitors and when it comes to digital cameras. It's important to understand, though, that RGB is device dependent, meaning your monitor is different than my monitor. My camera is different than your camera. Before you shoot anything, you should shoot for the end in mind. You should know what you're going to ultimately intend with the images that you shoot. Images do not live in the camera. Images are shot, those files are then put into your hard drive, and they're put as JPEGs or TIFFs or RAW files. We open them up in Photoshop, we open them up in Lightroom, we put them into iPhoto. There's a million different applications that we can put these images into. The project itself should dictate the color. And that's something that people need to remember. And so it's important to understand that when you shoot the images, these images are going to have an embedded profile. The embedded profile is an appearance indicator. It's like a name tag. Hi, my name is Mark, or hi, my name is Adobe RGB. And so if I walk into a room and I am an image that has the Adobe RGB embedded profile, I can go into any room and everyone's going to know who I am. There's no way to get around profiles. Profiles are everywhere, and we have to use profiles effectively so that color is maintained throughout an entire workflow. And that begins with the camera. When you choose JPEG, if you're going to shoot JPEG, then you also have to choose a profile. Well, which profile do I choose? Do I choose sRGB or do I choose Adobe RGB? What's nice about sRGB is that if you're shooting something for the web, then shooting sRGB is the most direct path to the web. However, sRGB is a limited color gamut for print. And if you're going to do multiple things with the image, then you're better off shooting with Adobe RGB, because if you're going to go to press, and if you're also going to print, fine art posters or fine art prints, or whatever you're going to do, more than just the web, then you want to shoot in a larger color space like Adobe RGB. With RAW, you've got a digital negative, if you will, and you can process that image any way you want. You can process it directly to whatever RGB color space or RGB profile that you want to. But if you don't want to spend time processing all those RAW files, shooting JPEG is fine. Properly white balanced and shooting sRGB, those images are ready for the web. They're ready for digital printing to a Noritsu. They're ready for digital printing to a Fuji Frontier. But if you're going to do more with those assets, then you want to shoot in those color spaces which give you the most flexibility. And that's the thing you want to remember. However way you set up your camera, you want those camera settings to translate to your display. And this is why you don't want to take your display for granted. You want to make sure that your display is calibrated and profiled. But the question becomes, calibrated and profiled to what? Some people think that you calibrate and profile to your printer, and you really don't. You calibrate and profile your display to a known visual situation, a known visual condition, if you will. And that usually means a particular color temperature and white point and gamma and luminance. What I really want you to consider is I want you to do your own experimentation and come up with your own color temperature, your own gamma, your own luminance. Now there are recommended ones. For instance, we at Encompass use D65. D65 is great for doing printing. It's great for going to the web. It's great for even press in a lot of ways if you're using press paper or if you're printing a paper that has a lot of UV brighteners in the coating. If you're doing a lot of straight magazine work, Time magazine, or any magazine that you're printing to, those papers tend to be very warm, so D50 or 5000 degrees Kelvin tends to be the more preferred white point. But you need to decide. And then there's gamma. Gamma is tone curve. Gamma is relationship of input to output. 50% in, 50% out. That's gamma 1.0. In curves in Photoshop, when you see that straight line, that's a perfect gamma curve. That curve is relationship of input to output, right? If I pull the curve down or push the curve up, that affects those pixels. So we have to choose a gamma which best reflects how we look at color in the real world. When we look at print contrast, if we look at gray ramps, if you will, our eyes don't see linearly. So we actually need gamma compensation on our monitor so that when we look at steps of density, those steps of density look similar to what we see in the real world. However, gamma is also a choice. Some people prefer gamma 1.8, some people prefer gamma 2.2. You have to choose. Just know that 1.8 tends to be a little flatter and 2.2 tends to be a little bit more contrasty. And then there's luminance. I learned a long time ago in color management that if you want your screen and print to match, then you have to match your whites. So your white point of your viewing environment needs to match the white point of your display. And that's something that has resonated with me for a long time. And with that, you also have to pick luminance. So how bright your display is, the brightness, the luminance of your display needs to be similar to the luminance that you're viewing your print in your print condition. Let's talk about a few instruments. So this is the Greytag Macbeth, now X-Rite I1 Pro, and it's a spectral photometer. It's used to calibrate and profile displays as well as build printer profiles, ink on paper, as well as even profile projectors, LCD projectors and such. It's highly effective. This is a colorimeter, and it is also made by X-Rite, which used to be Greytag Macbeth, and it's called the I1 display. This is called the Color Monkey, and the Color Monkey is a spectrophotometer, and it's also used to measure color from your display or from your print or from a projector. And then there's the Huey. So there's a wide variety of instruments. I don't really care which one you get, just get something and have an instrument to calibrate and profile your monitor, because if you don't and you do so visually, you're limiting yourself, because we all see color differently, and at different times of the day we see color differently, and we can be affected by background, we can be affected by lots of things, and so calibrating your monitor by eye is usually not as precise. It's much better to calibrate and profile your monitor with an instrument. Your monitor should have a neutral background. Why this is important is because if you have a very colorful background, then that can detract from when you're color editing. And if you've got a really loud, vibrant, beautiful, colorful background, then that can actually affect how you see other colors in Photoshop. So I prefer to use a neutral black background or a neutral gray background, like the background that I have here on the display. Next, I want to talk to what happens color-wise when we get to Photoshop. Now, this is something that requires that you color manage your settings. If you were to just install Photoshop fresh, the settings are really not set up for most photography, unless most photography that you're doing is only for the web. But a lot of us print, and so you're going to have to change your color settings in Photoshop. In Photoshop, you've got Edit Color Settings. There are lots of different color settings. By default, you have what's called North American General Purpose 2. Well, think about it. Adobe has tried to make a default setting for the average Photoshop user. That's kind of a tall order when you and I have different needs for our images. So you want to choose a particular color setting for your particular workflow. So you've got North American General Purpose 2, North American Prepress 2, North American Web Internet. Well, we at Encompass, we've made our own color settings, and we have different color settings for different types of workflows. So let's say that we're shooting for print. Then I have one here called Encompass Grackle 2006. What that means is I'm going to use Adobe RGB for my RGB working space, and I'm going to use Grackle 2006 for my CMYK working space. And I'm going to make sure that there's a color management policy of converting to RGB. And if the CMYK does not match, then it converts as well. So let's say I'm opening up an image that was shot by a photographer here in San Diego named Sarah France. And when I open it up, the image has a different embedded profile than the working space. So what do I do? That becomes a big question. This is one of the most confusing topics in all of color management. Do I convert to profile, or do I use the embedded profile? Or do I discard the profile? This dialog comes up, and a lot of times people don't know exactly what to do. Well, here's what I want you to understand. When you convert to profile, you change the numeric values in the file, but keep its visual appearance. So, if I go from sRGB to Adobe RGB, all I'm changing is the RGB values, but I'm keeping the appearance. If I go from Adobe RGB to ProPhoto RGB, I'm changing the values, but keeping the appearance. And that's what you want to do in a color managed workflow, is that you want to convert to specific profiles for specific purposes. So when an image comes into Photoshop that you shot, if it's in sRGB but your working space is in Adobe RGB, then you need to convert. If you shot an image and your image is in Adobe RGB but your color settings in Photoshop set to sRGB, then you're going to need to convert. So these images came from Sarah France. All of these images are in sRGB. So do I need to convert to Adobe RGB? Well, if I'm going to go to print, sure. If I convert to profile, I can choose a wide variety of different profiles to convert to. I can convert to a CMYK working space, Grackle 2006. I can convert to sRGB for the web. And if you notice here, if I turn the preview on and off, I don't see much of a change. Once again, supporting the idea of keeping the appearance but changing the RGB values. This is much different than if I were to edit assign profile. Right now it's at Adobe RGB. If I assign sRGB, you notice that all of a sudden the image desaturated. Now don't think that sRGB is bad here. It's just that's what's going on. You're changing the appearance but keeping the values. That's what assign profile does. If I need to get to sRGB because I'm preparing this image for the web, I want to convert. I convert to profile. I convert to sRGB. If I do that and hit OK, now the image is in sRGB and is suitable for the web. Here I'm in Adobe RGB. If I assign a profile, I change the appearance. Sometimes that appearance change is drastic, like in this image here. You can really see that the red desaturates. Now it's not that sRGB is bad or anything like that, it's just that's what it is. That's what assign profile actually means. Convert to profile. If I need to get this image into sRGB, I convert. And now it's in sRGB, but it still looks the same. And so really there's lots of ways to convert, and probably the most common way and the best way is to use perceptual as a rendering intent when going from RGB to CMYK. But you notice though there's a desaturation. The blue sky is not as vibrant. Now the blue sky is a little bit darker. But this is where you use your Photoshop tricks. Before you convert, you can actually do a soft proof. You can actually simulate this by going View, Proof Setup, Custom. I can actually choose whatever profile I want and simulate on screen, like if I were to go to Grackle 2006 with Perceptual. And I hit OK, I can actually go back and forth with a Photoshop shortcut, and I can see here the shift. And this is where you would do your Photoshop curves, you would do your all of the tricks that you know in Photoshop to make that conversion as nice as possible to the original. If you want to gain back some of that blue sky, you may need to do a level change, you may need to do a curve change or a saturation change in order to maintain that. The very last step is usually that the image goes to print. And so when it goes to print, we want to make sure that when we hand off that file, if we hand it off to a service bureau, that it's in a color space that they're expecting. So you want to ask them, should it be Adobe RGB? Should it be sRGB? Should it be profiled RGB? If you're doing your own printing, then you can send color to the printer based upon the color profile that you've either built or that the manufacturer has supplied for you. So maintaining integrity throughout the entire process of shooting, viewing, printing, where your file leaves. If you give it to an art director or if you give it to a printer, you want to communicate with them and make sure you give it to them in the proper color space. If they say CMYK, you need to give it to them in CMYK. But the question becomes, what's CMYK? SWAP, Grackle, SheetFed, Euroscale, Modern Postcard CMYK? There's dozens of different CMYK profiles. The same goes for RGB. Should it be an sRGB, Adobe RGB, ProPhoto RGB? Proper communication with your printer is key here. And if you're doing your own printing, then you can manage that process yourself. Why do we do all of this? What's the big deal about all of this? Well, all of that wonderful curve tweaking that you wind up doing, the selective color editing that you wind up doing in Photoshop on a calibrated monitor, you want to maintain that when you go to print as best as possible. You do a soft proof and you see the change on screen and you see how it gets a little bit lighter or a little bit darker. You want to make sure that you get what you see in the soft proof. In order to do that, you need to print a profiled output, plain and simple. So without it, you're just guessing. Without it, you're utilizing a profile that may exist from the manufacturer, or that maybe you're just sending Adobe RGB over because you think that's what you need to do. The prints won't come out as good. Adobe RGB is for editing. It's not for printing. sRGB is for editing. It's not for printing. Print spaces have specific profiles, and they're based upon the particular ink and the particular media. So remember, your image is going on a journey from the original profile that you've selected in the camera to the display to the print. Your color data is going somewhere. Selecting the color space in your camera is the first step in this journey. And if you choose sRGB, you choose Adobe RGB, you choose RAW, you almost don't need to worry so much about it. What you need to worry about is what happens afterwards when you get to Photoshop. Make sure that you utilize that sRGB profile as a source. Having a calibrated monitor is very important. Without it, we're all going to be looking at color differently. And what looks beautiful on your monitor may not look beautiful on someone else's monitor. Going to print, you need to communicate with your printer. You need to ask them, what RGB profile do I need to give you for this particular image to print properly? What CMYK profile do I need to give you in order for this image to print properly? And then you can convert to those profiles before handing over the image. If you're going to print to an in-house printer because you have a HP DesignJet printer, print through a profile. If you're going to print to a device or print to a technology that's pressed, soft proof. Every step along the way, you're going to need to make a decision. These little decisions that you make can have a little impact or a dramatic impact. And with proper communication and proper color management techniques, you can get the best out of all of your devices.
Just remember that even if you select the proper white balance, choose a color space that makes sense for the end result, and effectively use picture controls to create the look you want, the advanced color settings in the camera are only the first step. To truly get the best results, you have to adhere to at least a few of these practices for good color management. At this point, we will discuss the approaches and settings for shooting under multiple light sources or difficult lighting situations, such as fluorescent lighting in an office. Fluorescent light can be problematic for 3 reasons. First, industrial settings such as schools and offices often use the cheapest bulbs available. The most common choice, although not the only one, is cool white. Your camera offers 7 white balance choices for fluorescent lights. But if your assignment is to take photos in an office, are you really going to get up on a ladder to find out what kind of fluorescent light is in use? Instead, you might take a reference shot of a gray card and then color correct later. The second factor to consider when shooting under fluorescence is the CRI rating for the light. CRI stands for Color Rendering Index. This is a measurement of how much of the full color spectrum is being reflected by an object when lit with the light source being measured. The standard is daylight, which can reproduce the entire spectrum when used as a lighting source. An incandescent bulb can also reflect the entire spectrum. Therefore, the CRI rating for incandescent light is 100. If you look at an object under incandescent light or daylight, what you see will be the most faithful to the actual colors. Unlike incandescent lights, fluorescent bulbs do not reflect the entire color spectrum. Cool white fluorescent bulbs have a CRI of only 62. While they cast a light that appears white, the bulb is emitting an incomplete color spectrum. One of the most difficult light sources to work with is a low-pressure sodium vapor street lamp. This light has a CRI rating of only 25. Subjects lit by a sodium vapor street lamp may look almost monochromatic because the lamp emits just a very small portion of the light spectrum. Even if you were to color balance for the yellow hues, you will not be able to record accurately colored images. The third issue to consider when shooting under fluorescent light is whether your subject is lit by more than one light source, as in this image.
As a professional photographer, I'm often shooting on location. It could be in a factory, it could be in an executive office, pretty much anywhere. I never know where I'm going to end up. So understanding the color temperature settings on your camera becomes very key in understanding how to balance those light sources. When you first get started in photography, especially as a new camera owner, you obviously just set your camera in auto white balance. You know it as AWB is the setting. And what that does is it's kind of like a hey dummy, automatic mode for any lighting situation. The camera's doing the thinking for you. It's setting the color balance. It's taking in all the different light sources and it's saying, okay, I think this is what the best neutral color is for the setting, which is great. And for getting started, that's going to put you in the ballpark the majority of the time. However, as you start to get more involved in your career and your photography, you may, for creative reasons or personal preference, decide that you want to set the color balance in a different mode to get an effect you want. So we're going to talk specifically about color temperature, different light sources, and how you can control them. We set up a portrait here in the studio where we're going to have a variety of light sources to explain clearly how those different light temperatures are affected by your settings in your camera and also the lights. First off, we have a fluorescent light, which is going to shift green when your camera is set on daylight. We have tungsten lights in the background, which are going to shift orange, and then we have daylight, which is going to be neutral when your camera is set on the daylight setting. So for this first shot, what we're going to do is take an image with the camera set in daylight balance mode with just the fluorescent lights and just the tungsten lights that are going to show up. You'll see by the first image here that there's a very much of a green shift from the fluorescent lights and a very warm shift on the back wall from the tungsten lights. Okay, Archie, roll your head this way just a little bit. There you go, and then turn your horn that way just a touch and pull it back up. There you go. Maybe hold it more like you're going to play it. There you go. Okay, go ahead and move the mouthpiece that way just a touch. Bring the horn all the way against you this direction. There you go. Yeah, that's better. See a little more profile of it. And shift yourself that way just a touch. Great, right there. If we look at the histogram for this photo, we see a green spike starting at the high end of the midtones and continuing into the highlights. This is indicative of cool white bulbs. The colors look a little flat, and the highlights in his face have a definite green cast. These two features show what a low CRI and a green spike in the fluorescent source produce when you capture an image. Okay, we're going to adjust the camera setting here as far as the color balance, the white temperature from daylight to fluorescent. There are 6 different fluorescent modes on this camera, and I'm just going to shoot for the cool white. That's good. Nose this way just a little bit. Okay, then I'm going to shift the color balance over to tungsten, which is typically the little light bulb setting on your camera. And then I'm going to shoot one finally in auto white balance. You'll also notice that in the prior shots, in the background there's a green shift, and that's due to the neon clock that is in the back of the studio behind the wall. The next thing we've done is added a speed light onto the D300. The speed light is going to be balanced without any filtration on it for daylight at 5,500 degrees Kelvin. We have the camera right now set in daylight, so we're going to take a picture of Archie with both the camera and the flash balanced for daylight. Okay, you'll see in this image that the shadows are pretty harsh. The lighting overall isn't very flattering and doesn't have a lot of dimension to it. And you'll also notice that our background has gotten a lot darker. One more right here. Great. So the next thing we're going to do is add a plus green filter over the flash. What this is going to do is balance the flash if we change the camera setting to fluorescent. So I'm going to go to white balance mode on the camera. I'm going to wheel it over to the fluorescent tube. So now this fluorescent fixture over here and my flash are now casting the same amount of green, but the camera is knowing to compensate for it. Good, nose that way just a little bit. Little smile. So this light source is not flattering, so what we're going to do is move this off camera. So we're going to set it onto the accessory cord and take a look at what it looks like if we move it off camera. So we attach the cable onto the speed light and then onto the camera. We're still in TTL mode, and we're going to get this light source over to the side. Archie, eyes right down here in camera. Okay, relax. We can see that that light source has changed our shadows a little bit, but still overall not that flattering. So the third thing we're going to do is we're going to bring a panel in to make this light source much larger and more of a soft window light. So to soften up our light source and make almost like a window light, we've added a silk, a one-stop silk to the set. This is just a simple lighting tool you can buy at almost any camera store on a lighting stand. It's about 70 bucks. A lot of people, when they start getting into photography, will start looking at these things and saying, well, you know, I don't want to keep spending more and more money trying to learn if this is a tool that I want. You can do something very similar with a thin sheet or, you know, some sort of a white fabric and bounce the light off of it versus through it, and you'll get a similar effect. So we still have the plus green over the flash to balance with the fluorescent, and the camera is still in fluorescent mode. We're going to take a picture of Archie. Good. Take a look at that. You can see already that the light source is far more flattering on Archie. We've got some good definition. We're starting to get some nice shadows, and overall the picture is just far more to my liking. Okay, so the next thing I'm going to do is switch the white balance mode on the camera over to daylight, and I'm going to take the plus green off of the strobe, off of the speed light, and I'm going to turn off the fluorescent light. We're going to take another shot. So now what we have as far as our light sources are the speed light with a little dome on it to help disperse the light, the panel, which is now acting as our main light source, and you'll notice this is only a few feet away from them. So the actual light source is not the speed light at this point, it's the panel which has become the light source. It's much larger, much closer, which is giving us nice soft light on Archie's face and nice light in his glasses. I'm going to take another shot here. Excellent, let's take a peek at that. Nice, eyes right here, one more. Nose this way. Great, roll that head just a touch. A little grin, eyes right into camera. Perfect. And the final thing I want to do is the background area behind Archie is a little bit dark. So we have the neon clock back there, and I kind of like that green influence. It kind of makes it feel a little more like a jazz club or something. So I'm going to change my exposure for my ambient, and I'm going to open up the background so that I can increase the exposure back there. So I'm just looking at my in-camera meter and kind of basing my exposure back there off of my in-camera meter. Okay, Archie knows that way just a touch. Good, little smile right there. Nice, that's looking good. Super, looking great. Roll your head this way just a touch. And relax, got it.
Take a moment right now to pause this DVD, pick up your camera, and scroll through all the Kelvin temperature settings. You might expect the temperature values to go up in increments of 1000, but instead, the progression of values appears quite irregular. The designers at Nikon set the camera to increase the Kelvin temperature by increments of 10 myriads. Your camera manual mentions myriads, but doesn't do a very good job of defining them or explaining why they could be important to you. The word myriad is short for micro-reciprocal degrees. The best way to think about myriads is they offer a more uniform measurement for the color spectrum. This comes into play when using color correction filters. Filters come in various degrees of amber and blue and can be used to warm up or cool down the color temperature of your light source. Regardless of the light source, these physical filters will subtract the same amount of blue or amber light from the scene. Nikon engineers prefer to tie the settings on their camera to a physical standard. So, for example, these color-correcting filters shift the image 20 myriads in either direction. What if we express the color correction in kelvins? Let's look at how the blue filter affects color temperatures. You see a much greater change in temperatures when the filter is applied at 1900 degrees Kelvin than at 8000 degrees Kelvin. But the amount of blue or amber light subtracted by a filter is the same whether the light source is 1900 degrees Kelvin or 8000 degrees Kelvin. The myrid scale is standardized. A filter rated for a 20 myrid shift toward amber subtracts the same amount of blue light at the blue end of the scale as at the amber end. It's always 20 myrids. So, even though the camera's display is represented in degrees Kelvin, each click shifts the color temperature 10 myrids, regardless of where you are on the Kelvin scale. The increments for the white balance shift graph are also based on myrids. Here, you can shift the white balance toward amber or blue in increments of 5 myrids. Of course, it may be easier for you to simply think about these settings in terms of more amber or more blue. Even if you never think about color temperatures in myrids, it is important that you understand how color temperature settings and white balance shift emulate the physical filters that have been around for decades.
When we're talking about Kelvin temperature, basically it's set up so if you do 2 clicks, it's going to be 20 myrids, and if you do 2 clicks down, it's going to be 20 myrids the opposite direction. It's the equivalent of sticking these filters over your camera. One is going to warm up the image, and one is going to cool down the image. So I'm shooting tethered to the computer with View NX software with the Nikon, and I oftentimes will do this, especially when I have a client on board, because they can look over the shoulder of while I'm shooting, look at the images. We can make comments and changes, easily by looking at basically the final results. So I'm going to recompose here. I'm going to do another shot of Archie, and I've changed the shutter setting on the camera for a 2-second delay. I have a pretty long exposure in my background, and so I don't want to get any camera movement. So Archie, go ahead and hold still. Roll your head this way just a little bit. Good. Pushing the button, and we've got a little bit of a delay there. We'll take a look at that shot. Yeah, that looks good. And we can make some quick changes here. Look at the thumbnails. The client can take a peek at a few of the images that we've shot, and it's a great way to review your images and a lot easier to see and learn about your photography as you're taking photos. We've covered a lot of information. There's so many different settings in these cameras that can be really overwhelming. And the thing you're going to have to do is go out and shoot a lot. You're going to have to make a lot of mistakes, take a lot of pictures, but ultimately you're going to start to see the results that you want. A good way to organize your settings in your cameras is through the custom setting banks, which are A, B, C, and D, and the shooting banks. There's basically 4 drawers on either side if you want to look at it as like file cabinets. So as you start shooting and you start liking a specific look, get those settings all organized, put them into the bank, and then every time you want to shoot with those settings, you just go to that bank and the camera's already ready to roll.
You can also think of the custom setting and shooting banks as this camera's alternative to pre-programmed exposure settings such as landscape or sports. Let's begin by selecting Bank B from either the shooting menu banks or custom settings banks. The first time you do this, every menu option will be on the default setting. Make your adjustments. These will be saved under Bank B. Any change you make to the settings will be registered under this group. The next time you need to use these settings, all you will have to do is select Bank B, and the camera will automatically reset to this configuration. You can save up to 4 banks of information that stay in your camera, even if it's turned off. You can reset the custom setting or shooting bank at any time to the default configuration. Just select the shooting bank, then select Reset Menu. Only the selected bank will be affected. Over the course of this presentation, we have tried to give you more than just a guide to your camera's advanced settings. We have also tried to encourage you to think about what you as a photographer really need to get the results you want from this camera. The answer to that question will be different for everyone. Each of us has his own stylistic needs and preferences. Now it is time for you to explore all the various aspects of the camera to see how the settings fit in with your shooting rituals. Moreover, we challenge you to think of technology as a part of your shooting solution instead of the only solution. Remember to interact with your environment and consider shooting techniques that work with the elements you have on hand. If you really want to take your pictures to the next level, then pick up Blue Crane Digital's Advanced series through the eyes of a pro. This 2-volume set takes you far beyond camera buttons and dials. Through a series of interviews and discussions, Tim Mantuani describes a process and structure for photography that will get you thinking like a pro. He also walks you through a commercial photo shoot and explains the reasoning behind each camera setup. Here's one more thing you may find useful. Blue Crane Digital makes a laminated reference card for the D300 that you can carry in your bag. It's color-coded so you can find the answers to your questions quickly. It's called In Brief. If your local camera store doesn't carry the In Brief, then check our website for a list of retailers. We have covered a lot of ground over the course of this presentation. You will want to watch some sections again as you become better acquainted with your camera. What we hope you take away from the last hour and a half of material is a better understanding of how the advanced features work and why they are there. Be sure to practice what you have learned, then try out our exercises. And remember, sometimes the simplest solution is the best one. Thanks for watching. Now go out and take some great photos.